the second video of the exam review, and we're going to be covering sections 1.4, 1.5, and 1.6. So, the big thing with 1.4 is inductive reasoning, and it allows us to identify various patterns that are going on. Sometimes those patterns are obvious, sometimes they are not. It does take some thought. If it was just we add the same number each time, that's a fairly straightforward one. If it was we multiply by the same number every time, again, that one's fairly straightforward. But some of them, like this one, we do have to think a little bit more about, because 3 and 5, to get from 3 to 5, I added 2. To get from 5 to 8, I added 3. And some people would just go, oh, so it's 4, 5, da, da. But clearly it's not. 8 to 10, we added 2. 10 to 13, we added 3. So to get my next term, I need to add 2 to 13, and that's going to give me 15. Then I'm going to add 2 to 15, add 3 to 15, and I am going to get 18. Then I'm going to add 2 to 18 to get 20. Other than this, the other big topic that was mentioned and first discussed here are counterexamples. And the big thing to remember with counterexamples is we have a statement like if a number is divisible by, let's say, 5, then it is divisible by, let's say, 15. Now, this statement, we can find an example that shows this is completely false, and that's all a counterexample is. But remember, for us to actually have a counterexample, this part has to be true. So we need a number that's divisible by 5. In fact, let's be lazy and pick 5. And then we want to, once we have this, we've shown that it's divisible by 5, we now try to divide that by 15. So 5 divided by 15 is equal to 1/3. Okay. The fact that 5 is a counterexample just means that this entire statement is false. Okay. Section 1.5 talked about conditional statements. And conditional statements are always if the hypothesis, then the conclusion. Another way of writing that is if P, because P generally represents our hypothesis, then Q, or more simply, P implies Q. So this is the language that we have for writing out these statements. A standard conditional statement is what we have there. P implies Q. Converse is if our conclusion, then our hypothesis, or Q implies P. Inverse. Inverse is actually where we have to introduce a new term, and that term is a negation, which is denoted like this. So this would be the negation of the hypothesis, and really all it's saying is not P. So our inverse we could write as not P implies not Q. Our contrapositive we could write as not Q implies not P. Then we have our biconditional statement, and it can be written in a couple of ways. Here is one way. P implies Q, so if P implies Q and Q implies P, then we have P if and only if Q. Or another way of writing that is P Q. So we have a double arrow. And this was the real big stuff from this section. There are truth tables, but for truth tables, they're relatively straightforward in their construction. You ask yourself, is a statement true or false, and then make a determination from that. Then we have deductive reasoning, 1-6. Now with deductive reasoning, we really have two major things, the law of syllogism and the law of detachment. The law of syllogism states that if P implies Q and Q implies R, so if P implies Q and Q implies R, then P implies R. That makes relatively straightforward sense, and this is actually kind of used a lot whenever we're forming proofs, because we have one statement and that statement implies a second statement, and then that second statement implies a third statement, so on and so forth. Law of detachment is if we have P implies Q and P are true, then Q is true. This kind of goes straight from our truth table. So we have P, Q, and then P implies Q. So with our P, it can be true or false. Our Q can be either true or it can be false. Meaning our P implies Q, if both are true, then we have a true statement. If P is false, we have a true statement. Otherwise, if P is true and Q is false, this is actually a counterexample. That's how we set up our counterexamples, so it's clearly a false statement. So what does the law of detachment really do? It says, if we have this as being true, and this as being true, then we automatically know the response of Q, and it's very clear that this is the only part of the truth table where they match up. So that will do it for this video, and I will see